All right, so are you ready to dive into the world of DNA?
Always ready for a deep dive.
Well, today we're going to be looking at this really interesting discovery science video
Okay.
that's all about the kind of information that is packed into our DNA.
Yeah.
And this video features Dr. Stephen Meyer, and it gets into some really
Right.
thought-provoking stuff, even touches on ideas
Wow.
that have really big thinkers like Richard Dawkins and even Bill Gates kind of scratching their heads.
Yeah, it really does make you reconsider how we think about the word information when we start talking about DNA. you know?
Yeah.
We're not just dealing with the amount of information, we're also dealing with the type.
Okay.
And that's where things get really, really fascinating.
So let's break that down a little bit. So the video starts off by talking about Claude Shannon's information theory,
Right.
which basically says that information is all about reducing uncertainty. It's like, knowing that it's going to rain in Seattle in November
Right.
isn't exactly like groundbreaking information, right? But if you find out the score of that game you missed where your team won in the last second,
Oh, yeah.
that's information. That is valuable.
Exactly.
Yeah.
Shannon's theory actually gives us a way to kind of measure
Oh.
that amount of information based on how much uncertainty is reduced. And the video actually gives a really good example to illustrate this.
Okay.
They talk about flipping a coin versus rolling a die. So if you land on one specific side of a die out of 6 possibilities,
Okay.
that eliminates way more uncertainty
Right.
than just getting heads or tails on a coin.
So more possibilities, less predictability equals more information.
Exactly.
That makes sense.
Yep.
But then the video goes on to say that Shannon's theory doesn't actually address whether the information actually means anything.
Oh,
And this is where things start to get really, really interesting.
right.
Yeah.
Absolutely. I mean, think about it this way. Think about like a random string of letters versus an actual phrase like time and tide wait for no man.
Yeah.
They might both be complex, but only the phrase has any real meaning or purpose behind it.
And that's where Dr. Meyer's distinction between Shannon information, so that complexity, and then functional information comes in. DNA isn't just complex, it actually does something.
Yeah, that's the key takeaway here. DNA sequence isn't random.
Right.
It has a very specific purpose, much like a language.
That language analogy is what really clicked for me in the video. I thought
Yeah.
they did such a great job explaining it, where they were talking about, like arranging letters creates words and sentences.
Yeah.
And similarly, the order of DNA's 4 bases, A, T, C, and G,
Right.
determines how proteins are built and how our cellular machinery functions.
And Dr. Meyer, he phrases it so beautifully.
Yeah.
He says, the information in DNA is specific. The arrangement of characters matters
Yeah.
in that it allows the molecule to perform communication function.
It's like DNA has its own language that cells understand, providing instructions on what to build and how to operate.
Exactly.
That's what I find so fascinating about this concept of DNA as a language, as a code. It makes you wonder, how does this language actually work?
That's a great question. It takes us even deeper into understanding just how remarkable DNA really is.
Yeah.
So if we think about DNA as a language,
Okay.
what are its words and sentences?
Yeah.
How does it convey its message?
Yeah.
Well, in the language of DNA, the words are called codons.
Okay.
And they're made up of 3-letter combinations of those bases,
Right.
A, T, C, and G.
Right.
Each codon corresponds to a specific amino acid,
Okay.
which are the building blocks of proteins.
So it's like each 3-letter word is telling the cell,
Yes.
hey, put this amino acid here.
Exactly. And then these amino acids are strung together in a specific order, like a sentence, to create a protein. It's kind of like assembling a complex machine by following a super detailed instruction manual.
So DNA is like the ultimate instruction manual for building life. That's pretty amazing.
Yeah.
But it also kind of makes you wonder, how did this incredibly complex and precise language even come into being in the first place?
That's the million-dollar question, isn't it?
Yeah.
And it's a question that has sparked a lot of debate.
Right.
The video touches on the idea of intelligent design, which Dr. Meyer explores in a lot more detail in his book, Signature in the Cell.
Right. The video mentions that even Richard Dawkins, who's a prominent evolutionary biologist, has acknowledged the striking appearance of design in DNA.
It really is remarkable how even those who advocate for evolution through purely natural processes are struck by the uncanny resemblance between DNA and human-designed information systems.
He even compares it to machine code.
Yeah.
It's like the very structure of DNA is hinting at some kind of intelligence behind its creation. And then the video brings up another really intriguing comparison, this time from Bill Gates, who likens DNA to a software program, but far more complex than anything humans have ever created.
Bill Gates, somebody who revolutionized the world through software, sees a direct parallel between the complexity of DNA and the intricate code that powers our digital world. That's a pretty powerful comparison.
Yeah, it really gets you thinking. So we're left with this big question if DNA operates like a language or a code. And we know that languages and codes are created by intelligent minds. What does that tell us about the origin of DNA's information?
It challenges us to really consider the source of such intricate functional information. Can random mutations in natural selection, the driving forces of evolution, truly account for the origin of such sophisticated information? Or does it suggest something more, a guiding intelligence behind it all?
Those are some heavy questions. And the video doesn't shy away from them, even though it doesn't claim to have all the answers.
Exactly. What's important is that we approach these questions with intellectual honesty. We need to examine the evidence, consider various viewpoints, and be willing to question our assumptions.
I think that's what I find so compelling about this whole discussion. It pushes us to think beyond our usual boundaries and confront these profound mysteries of life.
Absolutely. The origin of life and the origin of biological information are some of the biggest questions facing science today. And the answers have huge implications for how we understand our place in the universe.
It feels like we've journeyed from this familiar world of human-created information, our languages, our codes, our software, to this incredible biological information system in DNA, which seems to follow similar principles but on a whole other level.
And that's the beauty of this deep dive. It really prompts us to confront those big fundamental questions about origins, about the very essence of life itself.
We started by trying to understand the kind of information in DNA. And now we're delving into questions about the origin of life. And the possibility of design.
It's amazing.
It's amazing how we went from that basic question, what kind of information does DNA contain, to like contemplating the very origins of life.
I know.
And the vastness of the universe.
It really shows how interconnected all these concepts really are. And the video really does a great job of laying the groundwork, helping us to grasp, the different types of information and how they're at play in DNA.
We've moved beyond just seeing information as a way to reduce uncertainty. Now we're recognizing that DNA holds this special kind of information. It's not just complex, it's functional. It has a purpose. Like the instructions in a language or the lines of code in a program.
And that distinction is so crucial. Just having lots of information isn't enough. It has to mean something. It has to do something. DNA's information guides the building of proteins, the formation of cells. It's essentially the blueprint for life itself.
So where do we go from here? What does all this mean for us? For our understanding of the world.
That's the ultimate question, isn't it?
The
video encourages us to keep exploring these concepts, to delve deeper into the arguments surrounding the origin of biological information. And if you're looking to grapple with these ideas further, Dr. Meyer's book, Signature in the Cell, would be a great next step.
You've definitely piqued my curiosity. I think I'm going to have to grab a copy and dive into those pages.
It's a fascinating read for sure. I think the real value of this deep dive is that it's really equipped us with the conceptual tools we need to engage in these discussions in a meaningful way. We're not just passively absorbing information. We're wrestling with its implications. We're considering different viewpoints and we're forming our own conclusions.
That's what makes it so exciting. We started with this simple question about DNA. And now we're pondering the origins of life.
I know.
The possibility of design. The mysteries of the universe. It's mind-boggling.
Absolutely. And as we wrap up this deep dive, I want to leave you with one final thought to ponder. We've talked about DNA as a language, as a code. But maybe it's even more profound than that. What if we started thinking of DNA as a story.
Mm.
A story billions of years in the maker, making a narrative of complexity and beauty a testament to the power of information to shape life itself.
Wow, that's a powerful image.
It really is.
Yeah.
It's a story that's still being written, and we're all a part of it.
And on that note, we'll leave you to ponder that story that DNA tells, the mysteries it holds, and the questions it raises about our place in the grand scheme of things. Until next time, keep exploring, keep questioning, and keep diving deep into the world of knowledge.